For our solutions to homework set number 5 for ECE 476-676 Advanced Embedded Systems. This homework set looks at using the graphics display on your Raspberry Pi Pico. So the problem here is to write the program for a little shoot game. So here's what that program does. When I start it out, it gives me a target that I want to shoot at. I'm going to specify, when I launch a tennis ball, the speed and angle. So launch at 60 degrees at 60 meters per second. And it then launches the tennis ball, shows the trajectory. When it hits, it tells me how much I missed. So I was 39 meters short. The goal of the game then is to sit there and guess again. Let's try 50 degrees, 65 meters per second. Launch the tennis ball again. It'll do some calculations, calculate the trajectory of the tennis ball, see where it hits, and now I am long by 64 meters. Try to hit the target. So that's kind of the game. To do that, what I'm going to do is include sleep, rand range, math library, LCD. I'll first initialize the LCD display, define a bunch of colors, clear the screen, then draw a box around the display, and then go into an infinite loop, or a loop. As long as I've missed the target by more than 1 meter, I'll do the following. I will ask you to input the firing angle and the speed. It will then display that on the LCD display. You'll convert to a text string and display the text string as white. That's the firing angle, then the speed, then do some numerical integration. Here's my initial spot is 0, 0. I will convert the speed and angle to the velocity in the x direction, y direction, my step size, and as long as I'm above the ground, keep iterating. So integrate acceleration to get velocity, integrate velocity to get position. As long as I haven't gone past the end of the screen, display it as a circle at your XY location. The screen is backwards, so the top of the screen is 0, bottom is 320. So this flips it, so it's going up from 310. As a circle with a diameter of 3, that's pink. Sleep point 1 second. Keep going as long as y is positive. If y is negative, I will back calculate where did I hit. So here's the 0 crossing, based upon the velocity, how much you below the ground you are, and where you hit. The error is how far you are from the target. Display that. And if I'm less than 1 meter away, the game's over. So that's kind of the game. The challenge then is try to get there in as few shots as you can. So you can do interpolation. I'm not going to do that, but if I say, let's do 62 meters per second, and 60 and 65, let's try 62 for the angle. Launch it again. See if it gets closer. And the point of this homework set is just to get used to using the LCD display. It's a really nice way of getting information out. In this case, what's going on, how much you're missing, some graphics. That's homework set number 5 for Advanced Embedded Systems. Kind of one sidelight. If I want to clear the screen after every shot, what I would do is, here's my LCD clear. If I do this, that clears the display after every shot. To illustrate that, let's do 60, 60. Launch a tennis ball. I lost my target because I cleared it. That's wherever the target is, I missed by 58. Okay, so I put that in the wrong spot. I'll clear it after I input my new desired spot, and probably want to put this in there as well. Clear the display, redraw where the target is, redraw my box and line. Let's see, run this puppy. 60 and 60. Here's my target. So it's 53 meters long. Let's try something a little bit less. Let's try 60 and 50. There, clear the display, redrew the target, redrew the line. Again, homework set number 5 for Advanced Embedded Systems. We'll be using the LC graphics display from now on. It's pretty nice.